part of my final assignment for machine learning, I am doing my final assignment project as credit card fraud detection using machine learning. Why is credit card fraud detection so hard? It's the needle in a haystack problem. Fraudulent transactions are extremely rare, and they are with millions of daily transactions, manual review is impossible, so we don't have a lot of data on it. Our goal today is to develop a machine learning model that automatically flags the suspicious few without blocking the valid many. So the daily operations can go on, but also we don't let the thieves get away with with fraud. My approach to this problem and the dataset that I'm using is the dataset is from Kaggle, and it contains approximately 284,000 transactions, and out of these, 492 are fraudulent, which is a high-class imbalanced data set, and 0.17% of these transactions of the whole data set is fraudulent, which means we have very few fraudulent transactions in this data set. So my strategy to this problem is I'm going to create a random forest model as a safety net benchmark so we can compare it to the neural network. And then for the advanced solution, I will build a PyTorch neural network. And the reason for that is that it allows more customization. Custom weighted loss functions handles the imbalance better than the standard models. I can do threshold optimization and weight it, the weights. I can update the weights. So the baseline model, I developed it, and the performance is high precision but lower catch rate. So um, the catch rate or recall is the most important part in this model, which is lower than what we'll see in the next model. How it works is that it uses decision trees. Um, to structure and filter these transactions, and based on those decision trees, decision and filters, it it either flags the transaction as fraudulent or non-fraudulent or just normal. In this confusion matrix, we can see that even though it's accurate, it still missed 24 fraudulent transactions, which for such a data set is a big deal, even though it doesn't seem like it is. So now we will look at the confusion matrix of the neural network. It has improved the recall or catch rate, which is very important, and also it has raised the fraudulent transactions to 88 and lower down from at the 24 transactions that got away. However, it raised more false alarms than comparing to the random forest model, uh, which was having three, but this has 1,034 raised alarms. So that means we would have to do some threshold tuning to balance the sensitivity so it is not so sensitive. Um, and our model has a 99.9% accuracy. But this is misleading because the data set is mostly of normal transactions. 99.8% of these transactions in this data set are normal transactions. So any model trained on this data set would uh, have around 99.9% or around 99% accuracy. Um, our real success is our recall rate. Our recall is 80%, which is the real king here. And because we tuned the decision threshold and we balanced its sensitivity, we also minimize the false alarms, the amount of false alarms that it'll raise for the catch rate, which makes it easier for the regular person to do business. Now I'm gonna show you the demo. Um, as you can see, it's a lot of code, and if I run each cell, it wouldn't be it'll be time consuming. So I have already run these cells. And this is the random forest model. that I have developed. The data set is downloaded here. This is the confusion matrix for the random forest, and this is the neural network. Its initialization. The training is here. We train the neural network on 80% of the data, and then the rest, 20% is kept test um, for testing. So this is the confusion matrix for, um, even though the screenshot one is different, I ran this again, so it's different, but and the accuracy is better. Oh, that's nice. So now I'm just gonna do a demo for you. So in this demo, the threshold is 99%, and it takes 10 different transactions, but I made sure one of those transactions is fraudulent, so we can see how the model does well. Because if I run this model on just like random data, like if I don't do that, it's hard to find a fraudulent transaction in such a imbalanced data set. So um, the risk score, it goes on risk score and this fraud detected, and that means um, it'll alerts us that fraud is detected, and then we can take the necessary actions. So what we learned from this was the summary of this project. Um, the challenge was to take rare fraud in a massive data set. We did that. We used robust scaling to handle the outliers of transaction amounts, implemented weighted binary cross entropy uh, to force the model to pay attention to fraud, and the weight was 507. And the outcome is successfully built and deployed. Successfully built a deployed model that filters transaction in real time with a high degree of reliability, which is 80% is a high degree of reliability. Thank you.